This Zoom session is being brought to you by the Fractal Horizon Labyrinth B. Today, we go on through 4.4 and 4.5, which I do believe finishes the chapter. Yes. So it'll be due next week. And 4.4 is about graphing linear inequalities in two variables, and 4.5 is about graphing systems of linear inequalities. A linear inequality in two variables. It's of one of these 8 forms. Ax plus by less than or equal to c, or greater than or equal, or less than or greater than, or more or less equivalent, y less than or equal to ax plus b, or greater than or equal, or less than or greater than. Its graph is a set of points where x and y fit the inequalities. So for example, 4x minus y less than or equal to 0. Does a half by 1 fit it? Well, you plug it in. 4 times a half minus 1 is 2 minus 1 is 1, which is not less than or equal to 0. So no, this point does not fit the inequality. Does 0.8 by 0.6 fit the inequality minus 5x plus 2y greater than negative 4? Well, you should plug it in. Negative 5 times 0.8 plus 2 times 0.6 is negative 4 plus 1.2 is negative 2.8, which is greater than negative 4. Okay. It's better to be $2.8 in debt than $4 in debt. So yes, this point does fit this inequality. When you graph a linear inequality in two variables, you get a half plane, for example. X plus y less than 1. Here's the dotted line is the line x plus y equals 1. And x plus y less than 1 is everything below and left of this line. X plus y greater than 1 has the same boundary, and it's the other half of the plane otherwise. X plus y less than or equal to 1 is almost the same as the graph of x plus y less than 1, only we include the boundary line x plus y equals 1. And x plus y greater than or equal to 1 is like the graph of x plus y greater than 1, except it too includes the boundary line x plus y equals 1. So I denote an included boundary by a solid line, an excluded boundary line by a dotted line. These ones where we exclude the boundary are known as open half planes. Those ones where we include the boundary are called closed half planes. Sort of like open intervals and closed intervals. All right. You graph linear inequality by first you graph the boundary line, dotted if it's less than or greater than, solid if it's less than or equal, or greater than or equal. Then figure out various ways of which half of the plane to shade in, this half or this half. So x less than negative 3x plus 2. Well, the strict inequality means it's a dotted line. We don't include the boundary. The slope of the boundary line is negative 3. Its y-intercept is at 2. And since we have y less than negative 3x plus 2, we'll color below the line. So here's the boundary line with a slope of negative 3 and through 0 by 2. And it's not included. We color below the line. So it's this half plane. Y greater than or equal to negative 3x plus 2. Well, it's like this, only it's the exact opposite. Instead of excluding the boundary line, we include it. Because it's greater than or equal rather than less than, we include the other half of the plane. So here. Now, graph x minus 2y greater than or equal to 4. Well, okay, first of all, because it's greater than or equal, we'll include the boundary line. Now, we can find the intercepts and graph the boundary line. For example, when x is 0, you plug in 0 in here, you get negative 2y is less than or equal to 4, and therefore y is less than or equal to negative 2. So here's a negative 2 and everything below that. When y equals 0, you plug in y equals 0, you get x greater than or equal to 4. So here's x equal 4 and everything to the right of that. So we include the boundary line to these two intercepts, and we go below here and to the right of here, which means this lower right half of the plane. Okay, some examples. Graph 3x plus y is greater than 2 plus x. Well, first we'll move the 3x to the right by subtracting 3x from both sides. So y greater than 2 plus x minus 3x, or y greater than negative 2x plus 2. We graph that. A greater than sign, so it's a dotted line, and y greater than that, so we call it above the dotted line. The slope of the line, boundary line, is negative 2. the intercept is at 0 by 2. So here's 0 by 2. We draw a line with slope of -2, make it dotted, and we color above, and this is the half plane. Graph y plus 4x is greater than or equal to 0. Like we transpose the 4x and get y greater than or equal to -4x. Greater than or equal, so it's a solid line. Y greater than, so we color above the line. The slope is -4, the y-intercept is 0, so the boundary line is this, and it's solid. We color above it, so it's this half of the plane. Graph. 0.3x plus 0.4y is greater than or equal to 1.2. Well, okay, just to neaten it up a bit, let's multiply throughout by 10 to get rid of all these decimal points. Then we get 3x plus 4y is greater than or equal to -12. Okay, greater than or equal, so it's a solid line. Now we'll try to find the intercepts of the boundary line. When x is 0, plug in 0 here, we get 4y greater than -12, or y is greater than or equal to -3. So it's 0 by -3, and y greater than or equal, so we'll color above it. When y is 0, we get 3x is greater than or equal to -12, or x is greater than or equal to -4. So here's -4 by 0. That's the other boundary intercept, and we color it to the right of that. So we draw this solid line. We color to the right of this and above that, in other words, the upper right half of the plane like this. Here we have graph y greater than or equal to -2.37x plus 1.5. Okay, greater than or equal, solid line colored above. Slope is -2.37, y-intercept is 1.5. So 0 by 1.5, slope of -2.37, solid line colored above this upper right half of the plane. Now here they ask, it's a reverse thing. Given a graph like this, what is the inequality with this graph? Okay, the boundary line goes through 0 by 3 and has a slope of -3/2. When you go over 3, it goes down 2, so a slope of -3/2. So, well, with that intercept and that slope, the boundary line is y equals -3/2 x plus 3. Now, it's a dotted line, so it's greater than sign or a less than sign. And it's a colored above, so we do a greater than sign. So y is greater than -3/2 x plus 3. And that's the inequality for this boundary, for this half plane. Here, it's find the inequality, everything to the left of x equals 3. This boundary line has the equation x equals 3, and then everything to the left of it means x is less than or equal to 3. Less than or equal because this is a solid line included, so that inequality.